we're given 3 squares. So, and we're also given that, so of course, these 2 squares share this edge. These 2 squares share this edge. And we're going to show that those 2 triangles, those 2 angles add up to become 90 degrees. That is AOD, this angle, and this angle, and this angle. So first of all, I can think of 2 methods. First method is I can use complex numbers. I will treat O as my origin and treat the vector OA as Z1, first complex number. Vector OB denoted as Z2, and vector OC denoted as Z3. And without loss of generality, we can just assume that the length of the square is just 1. Doesn't really matter what length you assume to be. So here, so Z1 can be represented in the complex number form. What's my real number part? The real part is easily just this part, that is just 1, right? And the imaginary part is just I, right? Likewise, Z2, my real part, OB vector, right? Real part is just 2. Imaginary part is I, and Z3, 3 plus I. Right? And to find out the angle sum, we just have to multiply those 3 complex numbers together. Because remember, according to the multiplication rule of complex numbers, we end up with a new complex number, and that new complex number has such following properties. Our new complex number would have the length that is equal to the product of the length of each of these complex numbers. And our new complex number, the angle of it, should be equal to the sum of our individual complex number angle. Yeah. So simply use Z1 times Z2 times Z3 is easily 1 plus I times 2 plus I times 3 plus I. And that is simply, so 1 times 2. I times I minus 1, right? 2 minus 1, 1. What's the I terms, right? 2I, 3I. And that is simply 1 times 3, my constant term. 3I times I, 3I squared, that's minus 3. So 3 minus 3, 0 already, being my real part, right? No more real parts. What's the imaginary part? So 3 times 3, 3I. Now I have 1I, so that's 10I. So really, my new complex number has no more real parts. Just the imaginary part, length being 10. What's the direction of the vector? Straight up, no more real parts, just point directly upwards, right? 90 degree. So really, I've shown that the sum of these 3 angles really add up to 90 degrees, right? Through use of complex numbers. And there is another method using geometry. Right? There is really a geometric method. So the geometric method would be, first of all, I noticed that this angle, AOD, is easily just 45 degrees, right? Because this line is just the diagonal of this square. Then I want to somehow move this angle COD up to here. Right? I want to somehow make up a equal triangle, right? Equal to OC, COD, somewhere here. Then I can have this angle is equal to COD. Right, then I can just draw another square somewhere here. right? And maybe up here, another square. Yeah. So I have two more squares. So I can then draw a equal triangle up here. So equal triangle. Right? So that way I can show that A, B, C, D, E, F, G, E, F, I can show that angle EOF is equal to angle COD, right? Then I can show that angle EOF is equal to angle COD. Now, then I want to show that the remaining angle, which is angle FOA, is it equal to angle BOD? Right? As long as I can show they are equal, then that means this angle plus this angle is equal to angle BOD plus angle COD, right? Then if I just add angle AOD, right, this angle plus angle AOD is automatically obviously 90 degrees, right? Because this is 90 degrees. Then I can show my final result. But can I show that first, right? So that means I probably need another similar triangle. All right. First of all, I want to use my triangle A, B, C, D, E, F, G. G. I want to show that triangle BOG is similar. BOG is similar. Can I show that? Is similar to triangle AO, probably not AOF. I want to draw some more squares, right? I want to draw one more square and another one more square up here. Then I can extend this diagonal all the way up to here. Right, still a diagonal of this square. Then I can connect those 2 points. Still a diagonal, right? A, B, C, D, F, G, H. Right? Then I have a triangle FOH. FOH. Can I show they are similar? I think so. As long as I can show that, first of all, do they have the same angle? Is angle BOG, angle BOG, is angle BGO, this 90 degree, is it equal to angle FHO, right? Is this angle a right angle triangle? Right angle? I think so. Why? Because this is a diagonal of a square, right? So that means this angle is 45 degrees. And for the same reason, this angle is also 45 degrees, right? This is also a diagonal of the square. So that means they add up to be 90 degree, right? So that means this triangle, this triangle, FOH, is indeed a right angle triangle, right? And the triangle BOG is obviously a right angle triangle because this angle is 90 degrees, right? It's a square, 90 degrees. Then all I need to show, if I want to show they're similar, first of all, I know they're both right angle triangles. Then I just need to show their they have two pairs of edges that have the same ratio, right? So can I show that the length of OG over the length of BG, right? So can I show that OG over BG, what's the ratio? What's the ratio? OG over BG, obviously 2, right? Because OG, the length of, let's just assume that the length of the side of the square is just 1, right? It doesn't really matter. So OG over BG is automatically just 2. Can I also show that, let's look at my triangle FOH. FOH, I want to show that the length of OH over the length of FH, what's their ratio? Right? OH, FH. What's the length of OH? What's the length of OA? First of all, we're using Pythagorean theorem, right? Length is just 1. So diagonal OA is automatically square root of 2. And the length of AH is also square root of 2. So the length of OH is twice of square root of 2. And the length of FH, also a diagonal, right? So also square root of 2. So easily 2. So that means we have another pair of edges that have the same ratio, right? So that means really, this triangle and that triangle, right? BOG and FOH are similar triangle, and right. So, and I've previously also showed that those two angles are the same, right? 90 degrees, right? FHO, and so this is fine. So that means I'm done. Because now I've shown that these triangles are similar. So that means their corresponding angles must be the same. So first of all, they have they're both right angle triangle, right? Then their corresponding angle. What's their corresponding angle? So first of all, corresponding angle is angle BOG, and the angle FOH, they must be equal, right? So BOD, same thing, right? Angle BOD is equal to angle FOA, right? FOH, the same thing, right? So they're really equal, right? Really equal. Because they're similar triangle, as I proven, right? They're really equal, right? And I have also shown that this angle is equal to that angle. That is obvious. I've already shown that, right? EOF COD, because triangle COD and triangle EOF are obviously equal triangles, right? So obviously, right? Because it has the length of 3 units. This side is 1 unit. This side is 3 units. This right side is 1 unit. And this is 90 degree. This is 90 degree, right? So triangle COD, triangle EOF, obviously equal triangles. And then they have the same angle, right? Same angle. So angle EOF equal to angle COD. Therefore, this angle equal to that angle. This equal to that angle. So BOD, angle BOD can be replaced by this angle. Angle COD can be replaced by this angle, right? So that means all I need to show is that angle AOD plus angle BOD replaced with this angle, FOA, plus angle COD replaced with this angle, angle EOF. Is it equal to 90 degrees? Yes. Like I said, angle AOD. AOD is obviously 45 degrees. Angle FOA is this angle. Angle EOF is this angle. This angle, and AOD, this angle. Obviously 90 degrees.